the finite element class that's in the finiteelements.py file in your FEUtils module implements, in principle, a generic finite element. It doesn't have any opinions about what the nodes are because you pass in the set of nodes when you set up the element. But we can't actually calculate on the generic concept of a finite element. We need an actual one or an actual family of them. And as we discussed before, the ones that we're going to look at are the Lagrange polynomials, so the polynomial spaces whose nodes are defined by an equally spaced set of points over either the interval or the triangle. And so we have the finite element type, and then we have a subclass of the finite element class, which is the Lagrange elements type. And so this one is the one which is specifically the finite elements that we're going to deal with. And in an object-oriented language like Python, the way that works is if we look at Lagrange element and look at its source, Lagrange element is a finite element. And so that means that all of the methods that were defined for finite element above also apply to Lagrange elements, except if Lagrange elements got its own thing with the same name. And we can actually see that Lagrange element only has one new method. So the only thing that changes is that the Lagrange element has its own initialization method. And what that means is that whereas when you make a generic finite element, what you pass in is a cell, reference interval or reference triangle, the degree that it's going to have, the degree of the polynomials, a set of nodes, and something that we'll deal with later. So whereas that's what you pass in here, when you have the Lagrange element, you've made a choice by having a Lagrange element about what the nodes are. So when you make a Lagrange element, you just say which cell you want it on and which degree. And knowing which degree, you know which nodes they are, and you've already written the function that actually sets up those nodes. So you're going to use that function in here. So the other thing to look at here then is this mystical line down here. And if you haven't built objects before in Python, that line is going to just look weird. So that line says, so I'm sorry, I can't make it scroll up anymore for the benefit of people at the back. That line says super Lagrange element self underscore init cell degree nodes. So this is the incantation which is required to call the initialization method from the parent class. So self.init is this guy, and that overrides the init method for finite element. And so what this says is take the superclass of me, from me using this object and call its init method. And so what you're going to do is, given cell and degree, you need to give this guy cell, degree, and nodes. So you're going to make the nodes here and just pass the cell that came in, the degree that came in, and the nodes that you've made into the superclass, and that will make a finite element, which is a Lagrange element, which has the Lagrange node points. That's, this is the wonders of inheritance, mechanisms for writing very, very few lines of code. So that's not going to take you very long at all, because that is literally one line of code when you do it.